Okay, so anyways, we're going to talk about automatic failover. And basically what we're going to do is that we're going to use these guys, two Raspberry Pis and an instance of RethinkDB in the cloud to like kind of understand automatic failover and how it works. So yeah, my name is Jorge. I'm a developer evangelist at RethinkDB. You should really follow me on Twitter. So before we start, let's talk a little bit about RethinkDB and the fact that it's a distributed database. So RethinkDB, as you all know, is an open source database for real-time web apps. It is NoSQL, which means it stores schemaless JSON, right? But the part we really care about is that it's distributed, right? And the fact that it's distributed means it is really easy to scale. So what makes it distributed? This is actually like a very complicated topic, right? It's like has all these things that I could talk about, but I am only going to talk about these two features, right? You could say that two of the things that make it a distributed database is that it makes it really simple to shard and replicate your tables, right? When we shard a table, we basically divide the data, split it off amongst a couple of nodes, and when we replicate it, we create copies of that data. Now, the second feature is that you can easily connect nodes to a cluster by using this join command, right? If I start up a new instance of RethinkDB in my console, I can say /join, and I can pass it to host, right? So that node knows that it needs to connect to another node somewhere in my network or somewhere in the, on the internet, right? So what is the problem? As of today, before 2.1, if one of your nodes went down, you had to manually decide what to do. Okay, so if one of your nodes went down, you need to say, well, do I want to wait for this node to come back, or do I want to remove it from the cluster, or do I want, there are all these like decisions that like people who are managing this database needed to make, right? So that's when automatic failover comes in, right? In this new version of RethinkDB, RethinkDB 2.1, we're going to have automatic failover. So automatic failover introduces, RethinkDB 2.1 introduces automatic failover, and it uses this consensus algorithm called Raft as like the implementation. So let's talk a little bit about replicas. We have two types of replicas, primary replicas and secondaries. Some people know these as like master and slave, right? So a primary replica serves as the authority on a specific piece of data, right? And a secondary replica is just a mirror of that data. Simple enough, right? Whenever you do a query with RethinkDB, it always asks for the data in that primary replica because it always wants to give you the most up-to-date and the correct version of that data. You can pass a flag called use outdated, and if you pass that outdated flag, it will give you data from either the primary or the secondary replica, right? But again, that data might be outdated. So automatic failover in RethinkDB does really, again, I'm simplifying things a lot here, but it really does like one very important thing, which is if one of your primary replicas goes down for whatever reason, like the server explodes or someone trips over a cable, right? Like, and you lose that primary replica, it makes sure that it takes care of promoting one of those secondary replicas to primary. So why is this important? The reason this is important is because if you lose your primary replica, you can no longer have up-to-date reads, right? You need those to basically have outdated reads, and you can't write to the database anymore. So that simple thing of promoting a secondary to a primary is actually a pretty big deal. So the cluster picks new primaries by voting, okay? Each node, and this goes a little bit into what Raft is and how it works. Whenever you lose a primary replica, the cluster votes for a new primary replica, okay? And that's kind of like how the system works. So now it's time for a demo, okay? Guys, this is going to be a little crazy, okay? I apologize in advance. In this demo, we're going to have 3 nodes. We're going to have first Redis Geek right here. This is one of my Raspberry Pis. We're going to have PyShark. Okay, there's a shark right there. And then we're going to have another node up in the cloud. Okay, this one has like a boring name. It's RethinkDB 32. Whatever, like this is not as special as my Pis. So Let's see. We're gonna erase that. So let's see what do we have to do. So the first thing we're gonna do is that we're going to start RethinkDB on our main DigitalOcean instance, which is RethinkDB 32, right? As you can see, this is already running. Okay, so I can skip that part. Second thing I'm going to do is that I am going to SSH into my Raspberry Pis and start RethinkDB. Okay, so let's do that. Here, well, and just in case, I am going to also SSH into my box. Okay, so first one, SSH into DigitalOcean. Oh, the size. There. Cool. Then I am going to SSH into PyShark. Cool. And then I am going to SSH into Redis Geek. Yay. Okay, so I just SSH into these two guys, and now I am going to start RethinkDB. I am going to just copy this and explain it in a minute. So what I'm doing here is I am starting RethinkDB, and I am giving it a name. The name is going to be PyShark, okay? And I am giving it two tags, Py and PyShark. I am binding it to all ports, okay? So, sorry, to all addresses. So basically, then I am also demonizing it. And most importantly, I am joining it to my first node. So this IP address is the IP address of this guy, of Mr. Boring, okay? So whenever this node starts, it's going to join the cluster. Let's go ahead and do that. And now if we go here, and we go to servers, we see PyShark there, okay? Now let's join Redis Geek. I'm gonna take this guy and do the same thing. And now it's refreshing, cool. And those three nodes are there. So again, this is very simple. We have a cluster of 3 nodes, okay? These two guys and my guy up there. So what are we going to do now? We're going to start RethinkDB, and we're going to check our servers. We already did that. Now we're going to insert some data. Okay. So I don't really care that much about the data. So what I'm going to do is that I am just basically what I'm doing here, and let me zoom this guy in. I am inserting some data from Reddit, from our RethinkDB subreddit, obviously, and I'm just inserting it into a table called data. Oh, actually, I don't have a table called data, so I have to create it. Table create. Okay, and now I insert some data. Cool. So what do I have here? If I query my data table, I have a bunch of documents, right? Let's get the count. I have 25 documents exactly. Okay. So now we can go to tables and click on data, and we can actually see that this data is in PyShark. Okay. So this table has 1 shard and 1 replica. All my data is in my PyShark Pi, right? So it's right here. Okay. That's what that means, basically. And so what are we going to do now? We're going to do our little first demo. For our first demo, we are going to change the primary replica, okay? We are going to move all our data into Redis Geek, okay? So reconfigure, let's zoom that in. You can always complain about the fact that if you can't see anything, that's fine. So it has 1 shard and 1 replica, and yeah. Cool. So let's do this. Now, if we go to tables and we go to data, we see that all our data is now in Redis Geek. Okay. So what I just did is I moved all the data from PyShark into Redis Geek. Simple enough, right? So let's see. What are we doing now? So now comes the fun part. Now we are going to disconnect our primary. Okay. We're going to take this guy, and this guy is connected to Wi-Fi through this like little USB thingy. Okay. This is basically the Wi-Fi adapter, and we're going to disconnect it. So this guy is no longer connected to the internet. Let's see. Just to make sure, let's go to our servers. Oh, and it's still there. Let's refresh this. It's probably that the UI is a little slow. Okay. Well, but now we get the issue, right? It says test.data not available. Let's see if that's actually true. If we query our data, error, right? Primary replica for shard not available. So what's happening right now? We moved all our data here, and then we disconnected this guy, right? This guy is no longer on the internet. So because we can't communicate with this guy, we obviously can't get the data because it's all there. Simple enough, right? The data's here, and I can't access the data, right? Cool. So let's do this. Now I am going to connect this guy again. And I am going to run the same query. So give it a minute. No. Okay. So it's okay. Now we get our data back. Did that make sense? We ran the same query, and now we get it because it's online. So what are we going to do? We are going to reconfigure this guy. Oh, I forgot to copy paste that command. So I'm going to come here, and I am going to now create 3 replicas of this table. What does that mean? That means that this guy will be the primary replica, but then this guy is going to have a copy, and Rethink32 is going to have a copy. There's going to be 3 copies of the same table. Okay. This might take a while. Oh, that was fast. Let's make sure that this worked. If we go to our tables, whoops. Okay. Let's restart that guy. Okay, so let's see. What's going on? Oh. So let's restart these guys. So and then nope, something died. So that's what happens when you run stuff. So what's going on right now, right? Right now, we have Redis Geek, which is our primary, and this guy is our secondary, right? So, so now we can, let's try to disconnect the primary and see how far we can get. So this guy's not here anymore. See if it recognizes that. And try one more time. Cool. So now what happens, right? We only have one server because PyShark is died, and Redis Geek, we disconnected it from the network. And now if we have data, it throws an error, right? Because we still don't have the primary replica. If we connect this guy again, which is actually what we did a minute ago. let's wait for it. Okay, now data. Cool, now we get it back. So we still can insert data, right? That's normal. And node gets promoted to primary replica. So what would happen, right, is that if we had this guy, and then, well, if this guy worked, so I'm just going to continue with the screenshots. So here's what's going to happen, right? If this guy worked, if both of them were up, and then we remove the primary replica, what the system would do is that it would promote the primary Rethink32 to primary, basically, right? So this is what would happen. Redis Geek would be out, and then this guy would be the primary now. And you could just do anything you could before. Why? Because you have the majority of nodes. And this is a really important concept, right? The reason why I have 3 of these is because you always need a majority to do anything, okay? So if I have 3 nodes and one of them disappears, as long as I have that majority, I can keep doing everything I can normally, okay? Now, what's going on now? Currently I only have 1, okay? So again, if I take out this guy again, whoops. Well, right, I could still not do that. Well, I couldn't do that operation. It throws the error, right? And I also could not do the insert. Okay. Again, same principle, because like it cannot be acknowledged by the majority. Okay. So if I go here right now, oh well, actually, if I go here, right, you'll see that right now this is secondary. This is still the secondary replica, right? But if I had these 2 guys, let's actually try that, okay? So let's connect this guy. One more time. Servers. Let's give it a minute. Okay, so what could I do? I could reconfigure this guy. And I could say shards 1, replicas 2. Now I can do that operation, right? But again, that would not be possible if I didn't have the majority. So let's take a look at the second example, right? So if we had main RethinkDB32 be our main server, and then we disconnected all secondaries, okay? So we disconnected these 2 guys, and we only had that one up there. We could actually still get all the data. We could run a query, and it will return the right result, okay? Why? Because it is the primary, okay? So as long as you have access to the primary, you can still execute those read queries, okay? But you wouldn't be able to write to it, right? Because whenever you do a write, you actually need to make sure that a majority of nodes acknowledge that write. Because the primary replica is connected, data can be read. But because the majority of nodes are disconnected, data cannot be written, okay? And that was going to be my demo.